Hello guys, so today we're going to be doing 53 maximum subarray. And basically it says, given an integer array nums, find the subarray with the largest sum and return its sum. And you can see in these inputs, we have nums equals to -2, 1, -3, 4, -1, 2, 1, -5, 4. And if you actually go through it, the largest sum of the subarray, you can see it will be this, which will equal to 6. In example 2, we have nums equal 1. And of course, 1 would be the returning value because that's the highest value possible. And in this, the highest value possible to get is the whole subarray, the whole list itself, which would output to be 23. In this, we'll be using an algorithm called Kadane's algorithm with a time complexity of O of n and a space complexity of O of 1, as no extra memory is needed. And to demonstrate, we'll have two variables which will hold a current max and a total max, right? And basically, it's going to be pointing at the very first value of the list. We don't want a variable called max cur equal to 0 or max total equal to 0, because if we had an array of all negative values like -2, -3, -4, and -5, right? If you have this would we're going to be using a max, the max function, right? That's the goal. So this would be -2 or 0. And obviously 0 would return. And we don't want 0 to return. We want -2 to return. That's because 0 is not even inside this list itself. So it's better to have it actually point at nums of 0. That way it can point at -2. Right? You get it? Okay. You're going to have a for loop for I in range so you're going to want it to iterate through the whole list, and you don't want it to start at the very beginning because we already have it initialized at the very beginning. So it will start at the very next value, which is 1, right? And you're not going to understand this until I show you fully, but you're going to have a variable called max cur, and it'll use the max function like I showed you earlier. It'll take in the current index of the list, or it'll pick nums of I plus max cur. So this is what Kadane's algorithm really does. This is like where the bread and butter comes. And max total will equal the max of what it finds from max cur. And if it's higher, it will place it at max total. Right? And all you have to do at the end is just return max total. See that? It's just that simple. That's how efficient Kadane's algorithm really works. But here I'll show you how it visually looks. Let's just have our code on the screen. Yeah, that looks good. Let's make it just bigger though. Right? Let's take this too and make it bigger. Okay. So we have, initially max cur this is initially, right? And max total, they're currently equal to -2 because they're pointed at the beginning of the list. And in iteration 1, this is where it'll start. At index 1, right? It'll compare nums of I, which you can see right here. Nums of I. Let's use a different color because honestly, I feel like it'll be better. So nums of I, which is -2. Should it take in -2 or should it increase the subarray? -2. Should I take in 1 or should I do 1 minus 2, which is the current max cur? Obviously, it'll keep 1. So max cur becomes 1, and max total will become 1 as well. Right. Hope you're starting to kind of get it. I'll draw out the indexes right here. Index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8. Okay. There we go. So now let's kind of draw out. This is so these are indexes. And this is max cur. Right. And we have max cur to be -2 and 1 right so far. Okay, so it'll be -3. Should it keep -3, which is at index 2, iteration 2? Should it keep -3 or -3 plus 1? And obviously it'll pick -2 because that's the highest value, right? So max cur gets updated to -2. And max total equals 1 still. It does not get updated because 1 and 2 are the 1 and -2. 1 is still greater, so it doesn't get affected. So let's go to index 3 now, iteration 3 now. And so we change this to -2 right here. Okay, so now for max cur, it's going to compare if is 4 or 4 minus 3 better, right? 4 or 4 minus 3. It's going to pick 4. So, because 4 is greater than 1. So max cur will be 4. And it updates the max total to be 4 as well. Right? So now we get here. Remember how I told you like the 4, -1, 2, and 1 is the max cur, is the max subarray. So pay attention to this part. So just pay attention to this interval, I guess. It's gonna pick between should -1, which is nums of I currently, nums of I, or should it add -1 plus 4? Because that's the value of max cur right here. You see that? It's referencing this value always. And it's obviously going to pick 3 because -1, 3, it'll pick 3, right? So in iteration 4, max cur becomes 3 and max total. This max total will still remain 4 because 4 compared to 3. I'm sorry if I'm explaining it really slowly, but I'm trying to explain it the best I can to make sure you guys understand. Okay, so now we're at iteration 5, right? We have a max cur, max total. Okay, now it's going to compare if 2 or 2 minus 1 is better. Oh, 2 or 2 plus 3 is better. Sorry. Because it's referencing max cur. And obviously it'll pick 5, right? So now max cur is 5. And this is where max cur and max total changes. Right? And here's where you see you'll find 6. Now in iteration 6, it's going to find if 1 or 5 plus 1 is better. And obviously 6. 6 is the greatest value for max cur. Oh shoot, I don't know what happened. But max cur becomes 6. There's 8 iteration, guys, so we're almost done. Stick with me. Max total gets updated to 6. You see that? Okay, now 7, iteration 7. This is where things kind of go a turn, right? It's gonna see if it should keep -5 or -5 plus 6, right? Max curl will be 1. So it's gonna be 1 because obviously -5 plus 6 is 1, right? So 1 is still greater than -5, but max curl will change to 1. Max total remains 6 because 6 compared to 1 is still 6 still rules 1. Okay, last iteration. Okay, now it's gonna compare. Should I keep 4 or should I do 4, or is 4 plus 1 better? Right? And you can see 5 is the largest number out of the two. So it's going to pick 5. So max cur equals 5. Max total equals 6. And you see how the output amazingly is able to find 6 just like right here. That's how good Kadane's algorithm is. And the time complexity is actually O of n. Because you only got to loop through it once. And space complexity is O of 1. It doesn't require any extra memory. But yeah. You basically just return the max total at the end. Return the max total, as we did in the problem. And let's submit. And you can see it works. It only beats 13.74, but this is the best solution I came up with. But yeah, I hope you guys thoroughly understand this solution. If you guys can fully understand this, then you guys will be able to figure this problem out, because Kadane's algorithm is pretty useful. But thank you guys.